Good morning. My name is Wanderley de S Alencar, and I will present the article An Empirical Methodological Study of Evaluation Methods Applied to Educational Timetabling Visualizations. This research was carried out by me as a doctoral student in computer science, by my advisor, Professor Hugo NASCIMENTO, and my colleagues from Informatics Institute of Federal University of Goiás State, a Brazilian public institution, and from Southern Oregon University in USA. This is our agenda for this presentation. We will have a brief introduction, followed by a short literature review. After this, the proposed empirical methodological study will be presented, as well the results of the experiments. Finally, we will present the conclusion and possible future works. It is well known and accepted by information visualization scientific community that assessing the quality and/or usefulness of a visualization is not a trivial task, as shown by several works: Schindler Carpendale, Lan et al., John Staskos, Wall et al., among others. Some difficulties involved during the process of visualization evaluation are to determine if it contributes to data understanding and analysis, it is expressive, easy to memorize, and aesthetically appropriate, it induces significant insights. There are two types of approach when evaluating. One, a generalist approach, where only generic and high-level features are considered. Two, a specific problem domain approach, where tightly coupled features of the problem are used. The current paper follows the second approach. It is an empirical study involving heuristic evaluation methods. It is applied to educational timetabling problems. The timeline highlights some works regarding the evaluation of visualization published since 2000. They will be described briefly. Zook et al. Employs 13 statements in order to evaluate a visualization's quality. For example, if it considers the Gestalt laws. Lan and Eisenberg performed revision works regarding visualization evaluation. Gomes combined insight and task-based approaches. And finally, Santos performed a study about heuristic evaluation to identify problems in visualizations. Closer to our research, Staskos proposed a value-driven evaluation that measures four aspects of the visualization: time, insight, essence, and confidence. Where is its drawback is to be only a theoretical work. Extending Stask's work, Wall et al. Applied 21 statements, which goal is to define a quantitative method to measure the previous four aspects. Our proposal was divided in three phases. First, to qualify experts in problem domain, the educational timetable problem, and heuristics used for evaluation. This was done in a 2 hours web conference section. Second, the individual evaluation of which one of the 5 visualizations used the heuristics of Zook et al., Forcell and Johannes, and finally Wall et al. The statement scores range from 1 minimum to 5 maximum. The rater also marks his confidence to each score: 1 for small confidence, 2 for medium, and 4 for total. Third, here the results are collected and analyzed. In the case of any change to the visualization, the process is carried out again. This was not done in this study. The experimentation phase involved 10 raters, 7 men and 3 human. 5 visualizations showed in the next slide. 3 heuristics: Zook et al., Forcell and Johansson, and Wall et al. 4 scenarios explained later. The visualizations are VIS T2D, a traditional 2D table view; VIS G, a graph view; VIS DC, a daisy chart view; VIS MDV, a multi-layer diagram view; VIS ETV, an enhanced 2D table view. The 4 scenarios are a combination of the incidence of 2 elements: statements weight and rater's confidence. In scenario 1, does not apply neither statements weight nor rater's confidence. In scenario 2, applies only rater's confidence. In scenario 3, applies only statements weight. And finally, in scenario 4, apply both rater's confidence and statements weight. In phase 2, the score of each statement in each heuristic was calculated multiplying statements weight, 1 for not applying the weight, rater's confidence, and the score assigned to the statement, from 1 to 5. The result was normalized to be on the scale from 0 to 10. The visualization score is the simple average of the individual final scores. The bar graphs show the results of the evaluation of 5 visualizations, 3 heuristics, and 4 scenarios. In the Zook et al., it's possible to conclude that, regardless the visualization considered, the use of rater's confidence did not generate statistical difference in the results. Even so, the use of statements weight in the problem domain generated statistical difference and was relevant in the final results. When analyzing the application of Forcell and Johansson, the above conclusion is also achieved. In the Wall et al., it is possible to infer that in any scenario, neither rater's confidence nor the weighting of the statement were able to induce statistical difference in the results. all results were validated by statistical test, normality test, and ANOVA. We conclude that only the association of the rates with the statements had statistical relevance during the application of the heuristics of Zook et al. And Forcell and Johansson. Applying Wall et al., neither the rater's confidence nor the weighting of the statements were able to induce statistical difference. Still in Wall, in any scenario, this ETV visualization is the one best evaluated, with this MDV and this DC occupying the second and the third places, alternately. For future works, we intend to 1. Perform a similar study involving a greater number of users, including non-specialists in information visualization and non-specialists in educational timetable problem. 2. Design and apply a heuristic evaluation method focusing on education timetabling problem visualizations. Thanks for your attention.